This video is about our Lord and Savior, Skeleton Modifier 3D. Look at this picture, what do you see? Do you see another small helper class like Bone Attachment 3D or Marker 3D that will help to glue shit together? Or maybe you see some potential modernization to IK integration pipelines? Well, what I see here is an animation player node, but like 100 times better. Follow me and your view of Godot engine will change to before this video and after it. Starting from the basics. Here is the guide Godot issued to review skeleton modifiers design and usage. Nothing crazy, and in my opinion the most important thing here is that we published and explained an order of execution for this node. And this is the first part setting it for success. Skeleton modifier is simple, documented and stable, and believe me, this is a very good quality for an engine where simply changing child node's order can have a drastic effect on the program. Skeleton modifier is a node, an abstract class open for inheritance, and it has a single method open for overriding aside from the standard package. This method does nothing, but it always calls after animation players finish their jobs for a frame, what guarantees that each time this method is called, the outcome of changes on your skeleton will be the same. Also, from the get-go, skeleton modifier has two fields: boolean flag that enables or disables processing of current modifier, and the float influence parameter. On a scope of one node, both of these parameters provide nice quality of life to user, but their true power will come to light a little bit later. So, reading the design language of this node spells a clear message. Skeleton modifier is an ideal node to change skeleton's pose. It has a natural access to skeleton, it provides the best time to do it by having a hook method, and it provides a stable outcome. And now, let's finally start to accelerate the chariot of madness. First thing I would highlight that you can have several skeleton modifiers working on one skeleton. In this case, they will be parented to it together and will be working in order, in a strict order in which they are shown in editor, from the top towards the bottom. If you will analyze skeleton modifier as a pose it enforces, you can find that you can either override the current pose by your data, or you can get the current pose, summarize it with your data and then reapply it. This means that skeleton modifiers can discard both additive and multiplicative changes. Another important thought about parallel modifiers that in nature, and by nature I mean physics and geometry sciences, very often complex motions can be split into several much easier to understand ones. For example, imagine we code some complex tentacles motion or some epic cape movement on the wind. Physics tells us we can split such cape's behavior into several components, for example, a separate process of reaction to wearer's movement, a separate motion to react on wind impact, a motion to describe cape's own weight and how it moves the cape down, and for capes specifically there probably will be the fourth component regulating the border values our cape can't go over for us not to finish in this situation. Now, my first instinct when presented with such a task would be to create a single modifier that, while being fully aware of such motion split availability, would just have them split inside the modifier as separate functions. However, if they can be split, there is at least some sense to not even have them in one modifier, for example wind component. Maybe we could just carve out the wind impact, and not only it will allow us to reuse it, now our wind will have its own meta fields. We already have implemented by engine ability to on and off our wind with this active field, and we already can control the wind's impact on our cape by this influence parameter. But capes are like a later addition and they have a big detachable vibe. Let's talk about tentacles instead. Tentacles are often parts of some creature's skeleton. They are not detachable. Now think for a second, what do we really do always with each modifier? What the words apply pose really do mean? Applying a pose is iterating over an array of bones and changing their transform. And iterating is a very interesting construction. Sometimes it's not even what we do matters when we iterate, it's what subcollection of items do we choose to execute our code on. Subcollection of items. Of bones. So in theory, somewhere here, probably even in the form of an expert field, I can have an array of indices, which will so happen to be indices of bones I want to ignore when iterating, or not ignore. So is it a bone filter? Now suddenly we are able to rule on what we will count as tentacle and what won't. Additive, multiplicative, dynamic influence from 0 to 1, applied by a bone filter. Some viewers probably already have deduced where do we go, but I didn't finish. Look at this. An external data usage. What a natural place to move to the next topic. Skeletal modifier is a node. This means that here not only we can script in additional function in the form of functions, we can add data handlers, for example export fields. So skeletal modifiers can have access to pretty much your whole game, every single layer of your design. I will later return to talk more about export fields, but right now I want to finally jump to an important topic of achieving godhood. One single code line stands between you and the new universe of abilities. Yes, exporting a field of type animation. You're welcome. So why am I so hyped? Well, an animation is a resource that is easily understandable by human beings, can be observed through editor's interface, and holds an insane amount of effectively packed data about skeleton poses. Skeleton's pose is essentially an array or dictionary of transformed 3Ds, and animation as a collection of poses is a dictionary of dictionaries, and as we actually are not bound by having one animation in our skeleton modifier, we can add another access to our space and say that here we have this structure. Every single time a skeleton modifier updates, we are free to change any of these parameters. Imagine that now every single animation you work with magically got one extra function call track that is being called in every single frame and provides a hook and is able to manage the animation player itself, for example change the current animation from the inside. Wow. And the good part is, even if you don't want to use animation as a literal animation, you can just have one frame static pose encoded as an animation format. Now, to illustrate my thoughts, let's look at some examples. We can do forward kinematics, for example a mentioned case of tentacles or capes, or honestly any boned cloth at this point. We can do inverse kinematics, and not only that, we can do dynamic IK. For example, in a fencing game, your character can dynamically adjust the shield to block the next incoming hit. This will look sick and not that indie at all. Another thing we often need is to control our torsos for shooter games. Look at the Deadlock's example. What a sexy gun following, am I right? Well, I didn't choose Deadlock randomly. Deadlock is a hero shooter. This means that here we have 20-something heroes, each of them must follow their gun with their torso, but all of them have different models, different skeletons, different transformation impacts on torso spine, etc. Now, if you have experience using blending tree, you can pause here to think about the sexiest solution to this problem you can imagine and skim it down on some paper. And now, imagine that to solve that problem, we just need one node in the tree. Your previous layer is some animation being played or something, so you have your base pose, like holding a gun looking at a neutral angle 0. Now what you do is you add here another modifier that is essentially an IK modifier, but with some extra export fields. Your first export field will be an array of bones, a white list filter, because you don't want to rotate whole body, you only want to rotate palm, hand, some spine bones, etc. And heroes have different filters installed here. And then your second export field here will be of type curve, and it will regulate the modification strength. Essentially, this curve holds values of lerping coefficient, in other words, how much of original pose does a certain bone have, and how much looking at IK target does it have. This way, you can do that your palm with coefficient 1 is on the AK target, but the closer you move to the spine, the less transformation you see, sort of like real body does distributing the transformation. Want to make your character more stiff? Lower the curve and delete a couple of spine bones from the list. Want them to be more adaptive? Add more spine to distribute rotation and allow more of it with curve. A slotted in node piloted by export fields. Now if you skimmed AnimationTree design, look at them, look at this idea, and then cry in the corner. Another handwave from AAA practices, stateless sub-animations for reactions. You know how in big games sometimes you get hit by a crossbow bolt, for example, and your body twitches? No staggers, no forced reactions, you can continue your current action, but you also have this small shoulder twitch animation layered on top of you. This is a theme I didn't touch on this channel before because earlier it required blending tree. Now, hold my fucking beer, just slap here a skeleton modifier and layer whatever shit you want. stateless animation layering off top of a code-driven state machine. And do you remember export fields we talked about earlier? Do you remember this influence parameter? Now, with that, what we essentially have an access to is a customizable animation, like they do in Mixamo and other animation banks. A bunch of sliders can regulate certain aspects of your animation, which I remind you is fucking layered in parallel. So that crossbow hit, now we can scale the amplitude of shoulder twitching depending on the damage we took from that bolt, and the direction of the twitching depending on the side we were hit from. Who is an indie game now, huh? And here a thought starts to slowly creep in my head. In our potential uses for skeletal modifiers, we went from relatively innocent ideas that are equally easily implementable with both modifiers and blend trees, to ones that honestly put blend tree in shambles. And I want to double down that idea some more by reiterating my main concern about animation trees. Animation trees don't scale all that much and are terrible at being clear what the fuck is happening. They are certainly nice for playing with sliders at small sub-function of your game, but like a small toy demonstrating engine's ability to add two transformed 3Ds together. But when you start to actually work on something bigger than 5 minutes demonstration, they grow quickly and start to obfuscate the process itself. Look at this shit. Do you know what happens here? And here? And here? What is the difference? Can I have a debug stop? Can I see a result of one concrete node doing its job before or after? Can I get a delta pause, please? Can I throw debugging line at the console? Debugging animation tree is a horrible experience. Every technology works nice when you apply it correctly, but in reality no one writes code without bugs. What debugging instruments do you have with animation trees? Well, fuck you is what you have. The closest thing you can get to understanding what happens is to grab some node tie and temporarily put it into output to try to understand what happens, but that is not even a debugging tool, it's a crutch to make the process a little bit easier to understand by bits. And the node types, I mean, what meta instruments do you have to describe your system? You pretty much have a name of the node and that's all. They have sliders, but those sliders are the same for everything and are not that customizable. Blend 2. Blend in value. Try to guess what it does by the name of the node and names of its two children. Now look at skeletal modifiers. They are code driven. Each line represents something. I can add breakpoints, I can debug in console, I can activate and deactivate them in editor, I can have completely customizable export fields, I can have reasonable variables name, I can have functions, I can write a fucking comment. I describe my reality with a set of understandable parameters which are completely on point and are about the solution. While AnimationTree locks you into having to manually track about 10 float variables that claim to translate into any state your system might be in, but each of them alone doesn't bring that much sense. This and the lack of transparency in what system's components do in separation lead to AnimationTree being a very obfuscated system. This disease has a name and is called overabstraction, and overabstraction is a serious problem. It plagues the big world of programming as a whole, it takes time and resources to fix, and it always is an unpleasant experience because in essence you need to undo already finished work. And let me tell you straight, having overabstraction imposed on you by visual programming tool on an indie project that you do as a hobby for free without any corporate culture requirements and annoying absolutist colleagues is an absurd situation to be in. And a final argument that might not be so strong for some, but for me it's probably one of the defining ones for my choices. This process is called animation layering. Layering. Answer me this one question. What better explains the concept of layering animations to your monkey brain? A tree structure that you need to traverse from several leaves simultaneously to understand what happens, or, you know, a literal layered presentation like a list of layers put in order they are processed on top of each other. Again, this is personal bias and preference, but for me, with time I came to the conclusion that the more insane shit I am going to pull off, the better and simpler metaphors and images I need to use for the piece of meat inside my head. After this little warm-up, I am going to shatter your world picture and the way you looked at Godot animation frameworks. We are going to space and beyond. Let's start with an important notion about modifiers. For a skeleton modifier, it never matters what was before and what will be after. It just takes the skeleton in its previous state, bends it whatever and calls it a day. Also, if a modifier does not have a bone filter installed, has an influence parameter of 1 and completely overrides the previous pose, any previous processing on the skeleton stops to matter and might as well not exist, including the animation player itself. So, I have an interesting idea for a skeleton modifier. Let's create a modifier that can count time and has a field of type animation. Then in each process modification call, I want to absolutely force a certain pose in an overwriting fashion. This pose will be a pose the skeleton would have if our animation was played and had a certain progress. Now, as we can count time, this progress value can also be dynamic and change one by one each time unit. Finally, as animation is changeable field too, let's add an API call that will be able to change it. I will call this function play, and as argument it will take a string that will be a name of an animation we want to switch to. Enough. You probably understood where this is going already. It works. For example, here are two models. One runs because it is animated by an animation player, and the other one runs because it is modified by our new fancy toy. The real question is, why the fuck would a sane person do that? Animation Player is a built-in class that works in C++ as part of an engine, and this bullshit is a parody self-written in gdscript. Let's introduce a real-world challenge. So here's a running animation. Now let it be that we progressed in it for a half of a cycle and now are touching the floor with our right leg. And the next thing I want to do is to press sprint button and start to play sprint animation. Also, as our new animations are different, to escape sudden leaps I want to blend it with the next animation. My sprint animation starts from touching the floor with its left leg, so if we will transition right away, our character can't escape a strange period of mixing two poses that are too far away, resulting in gibberish. Alternatively, I can request the second animation without blending and then immediately seek some progress inside the second one, but then I can't have blending and will have a leap. No combination of play, seek and advance method can help us if we are a simple, classical animation player. We sort of need a completely new call, transition or seek and play or something. Some new function that will take 3 arguments: the next animation, the timing inside that next animation and the blending time. Visual programming connoisseurs might tell me that AnimationTree can easily provide me such a function for synchronizing my legs, but general wisdom tells me that there is no miracles in this world. If some data needs to be processed by hands on the abstraction level you are in, no matter what algorithm you will choose, you will need to process the data by hands unless you will leave an abstraction level. And it is perfectly illustrated by this blend to node. So how will our transition look? We will have an animation that we will transition from, we will have another animation to what we will jump, and a seek time node, and we'll have a blending node that progressively increases the blending coefficient from 0 to 1 over the blended time period. Now, not even talking about this tech requiring you to use AnimationTree for your project, you need to manage this blending coefficient. Somewhere in your program, something must actively move this slider over the course of 0.2 seconds. This means you do write this functional, you do process your data by hands, and this blend2 node essentially masks one line of code, this one, lerping between two transform 3Ds with some coefficient. But when we have established that some data needs to be processed by hands, what toolbox will you choose to do it? Will you choose a third-party black box technology without debugging mechanism and access to internals, or will you choose a first-party toolbox that is code-driven and is literally written by you? The question is rhetoric for your interest, so let's create this new function. I will call it transition. First argument is an animation name, then the timing inside it, and then the time period over which we must blend them. Now our cycle consists of 3 steps. First we update time, we count the delta between two calls for modification processing, we update animation progresses, and if they are cycled we undergo a cycle switch. The second step is to update blending constants. We have 4 of them. If blending is a flag that tells us if if we do any blending currently. If we do, we also track blending progress and blending percentage, which is essentially a normalized value that this blend to node changes. If blending percentage reached 1, it means that we've finished the transition. In this case, we make all variables that describe current animation to describe the next animation instead, because they now are essentially one entity. And finally, we update bones. A lot of boilerplate shit happens here, but only 3 lines really needed to understand what do I do. I calculate the state of the bone in current animation using progress, then I calculate the state of this bone in the next animation, and then I pose this bone in the skeleton using a linearly interpolated value between these 2 poses. And interpolation coefficient here is obviously the percentage of the blending transition. If we don't blend, this coefficient is 0 and we essentially just play the current animation. Here is a demonstration. These animations are very good, and one of their pluses is consistency. Each cycle starts from the left leg down and right leg up, being ready to start the next step. This allows us to sort of consistently know what leg we are in. Now let's make our dummies to cycle between jogging and sprinting animations, and as we said, we purposely request them to transition between different legs positions. Our animation player dummy only has a classical play solution with 0.2 seconds to blend, but another dummy will actively count the cycle progress and will transition according to percentage of the animation it is in. Yeah, we clearly have a winner. Now to the juicy part. Your bets, friends. What do we have in terms of performance? Are you a believer, or are you a hater secretly wishing this thing was 10 times less performant because you can't outrun C++ on an interpreter into C++? Well, here you go. These are 2 performance graphs, one for modifier and one for animator, and I won't tell you which one is which. So this really needs better benchmarking, because obviously on the scope of such a small scene it's hard to measure the noise is comparable with the value. But one thing I might say for certain right now. This technology at least works at similar speeds with original, and again, for something that is written in gdscript, it is quite an achievement. But please, don't make the wrong conclusion. It is not me, the genius, outperforming pathetic Godot designers with weight on my legs. No. Built-in animation player does a shit ton of work. It works with all other Godot, it accepts a bunch of track types, it can call functions, it has API, it works with tree, it works with a wall load corner cases, it works with empty tracks and reset values so it won't break if we'll ask it to blend 2 uneven animations. But my stuff doesn't do even 5% of that. It works with an implication that I only do skeletal animations, that I only use 2 types of tracks, and that all my animations have a track per bone always unchanged. This is a lot to assume, my friends, but as I am writing my shit for my project, it doesn't need to be universal, it just needs to solve my problems, so I'm good. And if this story has some morale in it, it is not about outpacing C++ on gdscript, it is about outpacing the broad heavy solution to all sorts of problems on a very thin and very specialized instrument specifically designed to solve one class of problems in ideal circumstance. Understand that, please. It is also about how powerful and nice refactoring can be. I remind you that on paper this functional was with us all this time in form of these 4 functions in Skeleton 3D, but using them was ugly, obscure, and felt like trying to augment a living being with a wooden implant by nailing it directly to flesh with rusty nails. Now, simply making a better abstraction that is nicely slotted into the execution cycle and produces stable results instantly made this thing into a godsend technology. But I'm not even close to finishing. Rewriting base animation player to add a new function is a gimmicky task, nothing more. Let's talk about higher level pipelines for world domination. As I previously said, we are aiming to create an ultimate workflow for a system that is able to layer animations, and the logical approach to architecturing such a system is to build it from the bottom up. First step you need is to think, decide and document what will be the bottom layer in your framework. It can be anything: animation player, this stuff of 2 players, AnimationTree or skeleton modifier that does not have any bones filtered out and has an influence of 1. The reason this layer is so important is because it kinda supports quotes base feature kit of your game or your prototype. Anything that you put on top of your base layer is probably a filtering modifier or modifier with influence of less than 1 or both, and to be supportable you need to have a nice parallels drawn between features and those modifiers. Your game should work nicely if you just block a modifier from editor and stop using a feature, and overall, as layer 0 powers like 90% of your systems, naturally it is the most important thing to build nicely. Let's build an ultimate one. I want to start from silencing all squeaking voices from the corner that are still there and insist on that AnimationTree can provide some functional that will be needed for a AAA game and is unique to that blending technology. For example, this pack I have provides 8 directions for jog start and jog animations. Despite me living with PC and keyboard, I understand that controllers exist, and controllers provide a non-discrete directional input in form of the vector that comes from the teeth. Now, wouldn't it be sexy to have 2P animations instead of just 8? AnimationTree has a from-the-box solution. It's called Blend Space 2D. Drop there 8 animations and you are good to go. Well, if it blends transform 3Ds, it can be coded down. And I did. Here on your screen you can see a modifier that uses a dictionary that maps 8 vectors to a corresponding animation. It works. This is the demonstration. This character actually has 2 states that use this technology. Both jog start and jog are fueled with such mixing. As you can see, it's powerful as fuck. I can change directions during starting animations, they all look natural and they can transition to jogging absolutely seamlessly thanks to the otherworldly asset quality. And this is the code of these states. Like, in some they have 40 lines, but that flexibility didn't come from Enter. I actually have a much more powerful construction built here, but as always I want to demonstrate you the thinking behind it first. When we wrote 2 powerful skeleton modifiers, it is really obvious how uncanny similar they are. Look, both Animator and Blend Space Wannabe have almost exact structure. First, they update some internal parameters, be it a time management or some internal logic, and then they update skeleton's bones. And the bones updating methods also are mostly the same. We iterate tracks, we find bones, then we do some animation-based calculations and transform the bone. More of that, this project actually uses animation-based root motion for its simulations, at least for now. So I have to write methods to get root velocity from them. Look at them, they are almost the same. When I look at this level of being similar, my mind screams at me to define a common ancestor because I might miss something important. And I do. And I did. To unlock your out-of-the-box thinking, I need to remind you that skeleton modifier is a node, as all nodes, and a script, as all nice things. In essence, skeleton modifier is just a hook providing technology. Very important, very needed hook, but just a hook. In pseudocode, your work in this method looks something like enforce pose. Now let's rephrase it until it makes sense. Enforce pose can be made much more scalable if it will actually made into a function enforce that takes a pose as an argument. Now, as this pose is just a slotted in argument, it sort of doesn't matter from where did it came. Pose equals something provide pose. Though looks small and unimportant, this construction will later help us to transcend humanity, so let's sort of photograph it here and store. Now let's suddenly look at the problem from another angle. I have already 2 kinds of states. I have an idle state that is a canonical move in all its glory, it just wants to use a simple animator and cycle a 10 seconds animation around. I also can imagine having some attacks as default animations. But simultaneously I have jogs move family that needs a special treatment and wants to use this blend space 2D-ish technology. This can be done, and it was done in such a way previously for this project that states can do a lot of micromanagement on Enter. They basically set up the needed player to walk, enabled it and disabled all the other ones. So I sort of had not one but multiple level 0 layers, and only one of them was used at any given time. But firstly, that was ugly and bred a lot of boilerplate copy-pasting to manage all that bullshit, and secondly, there is an important problem to solve still. Smooth transitions inside one level 0 animator are done with special animators that do work smoothly, but how will you implement a smooth transition between two different level 0 animators? The problem is not that easily solvable if you think purely in skeleton modifiers. The best of the worst solutions was some extra layer that dynamically manipulated those level 0 modifiers influence parameters that would allow them to be mixed together, but first, that was again ugly, and secondly, with that solution, Godot's internal workflows would get in your way because animation layers are overriding each other, and if you want transition from one level 0 modifier into another one, you either swap between increasing the second animator's influence to 1 and decreasing the first animator's influence to 0, if that makes sense, or even worse, you dynamically cut them from the tree and reparent lower for it to be processed later. Both solutions honestly suck. This skeleton modifier technology's best fit is being stable and immune to Godot's node processing order bullshit, and having node processing order bite you in the ass like that defeats the purpose, and with time the problem will only grow because at any given moment there will be some current level 0, some next level 0 and some other levels 0 that are not processed at all, and then your head will explode. Now let me ask you one thing. If you have multiple level 0s that need to be managed by another complicated layer, don't we lie to ourselves here. Level 0, my friends, is a single entity. If there are several candidates that take that role and are managed by some other layer, then in reality that managing layer is the real level 0, and your different animators are just its delegates. Now look again at this photo. Skeleton animator formed by some other layer, by some delegate. Now it's all coming together, and finally, as you might have noticed, what I do all this time is I steal nice ideas from AnimationTree parts, I just steal the good bits and ignore the bullshit. And what would AnimationTree connoisseur tell you if you would be in the situation of several animators being in charge one at a time and mixed on transitions? They will just slap there a single transition node and call it a day. And this, ladies and gentlemen, is what we would do, because if you have forgotten, everything in this goddamn world is a state machine. And when you will come to the conclusion that you want in fact one skeleton modifier to be your level 0, a portal to heaven will open above your head and you'll hear a divine voice with thick Russian accent speak to you. A skeleton modifier only provides a hook to the ideal place to enforce a pose on your skeleton, and pose calculations can and should be delegated if you see fit. Now let's create a base class that I would call a bone modifier. Its base implementation will have an access to skeleton because they all use it. It will have an access to animation player because feeding on its rotten flesh is a tradition for skeleton animation frameworks, and it will have a field to store the last player input the system got. It will contain 4 methods that we have already seen in previous skeleton modifiers. Update parameters will hold time calculations and all necessary things we need. Suggest bone pose will return a pose on request. Currently it returns an array, but that's a temporal measure until I find some better refactoring paths. And finally, it will be able to provide roots bones velocity on request. These two are utility stuff. Here I have 2 new bone modifiers, one for simple animation player and one for the locomotion mixing. They are literally 99% copy-pasted from their skeleton modifier relatives. They just return the pose on call instead of actually enforce it on a skeleton. And here we have the hero of the day. Transition skeleton modifier. It contains a bunch of bone modifiers as states and it delegates its calls to them. There is always one current state, and if you actually are in the process of mixing into something, we ask both current state, next state, and we mix those inputs. And I want to stress your attention again on how good are boons of polymorphism gods. My states only know this node as field called main animator, but my simple animation states ask it to transition to simple animation player, and my complex locomotion states ask it to transition to that 8-direction locomotion mixer. And because this thing here is a sort of overarching API gate, it works. Inside I always call this internal method transition to next modifier. But for the outside users, I can open bridges that will take their data, set up the needed nodes, and only then execute internal transition. Look how powerful this is. I have several states that can have infinite amount of animations, and half of their code is just a static mapping of their direction spectre, which honestly might be just carved out of here, called resource and exported. This is my level 0 currently, but I also want to highlight how similar it is to a bone modifier itself. It updates parameters, it enforces a node, and it provides a root velocity. And if so happens that I will want some other bigger construction to be my level 0, only about 10 minutes of refactoring separate this thing from being another layer of bone modifier, because nothing in this world forbids a bone modifier to contain a bunch of other bone modifiers. So, drawing parallels with AnimationTree, this thing here is a base class for animation node, and its layers are concrete implementations like blend, add, transition, blend space 2D, etc. They're just better, honestly. Conclusion. This shit is insane. Capabilities of these systems are through the roof. Welcome to the new reality. 3D pipelines in Godot are real. Like, subscribe, Discord, Patreon.